Hi, Assalamualaikum warahmatullahi wabarakatuh. Well, in this video, we're going to continue with other operations with matrices, such as we're going to look at matrix multiplication first, and then we will move on to understanding a simple idea about power of a matrix, and then we are going to talk about the transpose of a matrix. All right, without further ado, let's talk about the matrix multiplication. Here we have matrix A defined as such with all the elements given here in this square bracket. So matrix A has m times n size, and here we have another matrix, matrix B, defined as such, and this matrix here is of a different size, n times b. Therefore, the product of A and B is just going to be a different size of a matrix, which is m times p, and it is given by this mathematical notation here, mathematical expression here. We can have the element of Cij being the new matrix in this right hand side of the equation here, and in order to get all the element in matrix C, the process is given by this mathematical expression here, and I'm going to just explain what is it all about. Okay, right. So here we have two matrices, A and B. So here A is defined as Aij, the size is m times n. Right, so we can imagine having this matrix A11, A12, and until A1n, and then we move on to A21, A22, A2n, and until the last row, which is the mth row. So here we have AM1, AM2, and AMN. So that is matrix A. The size is m times n. Okay. Next, we look at the other matrix, which is matrix B. So here we have matrix B defined as such. We have Bij, and the size is n times p. So n times p. We can imagine the elements written as such. We have B11, B12, B1p maybe, and then we have B21, B22, B2p, and then we go to the last row. The last row is the nth row. So we have n1, n2 until np. All right, for two matrices to be multiplied together, you have to make sure that this one here is the same as this one. So that means the column of the first matrix given here has the same value as the rows of the second matrix. So you need to make sure that the values here are the same, so they match each other, and so the result of multiplying these two matrices will give you a new size of a matrix, where the matrix has the size of m times p. So here we have an m times p matrix. Well, we can imagine having these elements written as such: C11, C12 until C1p, and then C21, C22 until C2p, and it goes on until CM1, CM2, and CMP. Now, this formula here tells you how to get the values for each element in this new matrix. So basically, if you are looking to find the result for the first position here, C11, what you need to do is you need to consider this first row with the first column here, And in order to get the result of C11 here, it will be, let me just write down the process. It will be A11 multiply with B11 plus A12 multiplied with B21, and it goes on until the last element here will be multiplied with this partner. You can think of it as its partner. So you get one result, and this is a process explained by this mathematical expression here. Okay, so basically in order to get the result for C11, it will be the process of multiplying A11 with B11 plus A12 with B21 with this guy, and then you continue in this fashion until the last item here. So we have A1n multiplied with the last item in this first column, which is Bn1. So that is the result here will be plugged in into this position. Now let's try perhaps understanding how we can find the result for example, this position. So for this position, what you need to do is you need to, because this position is at the second row and second column, so therefore you're going to consider the second row here with the second column, and we're going to repeat the process. So here we have C22 can be obtained if you consider A21, the first element here, multiplied with the first element right here. So here we have A21 times with B12 plus A22 times with B22, and then you go on in this similar fashion until the last item here. So A2n times with Bn2, and basically all of this is generally expressed using this formula given here. All right, and maybe if you want to be more confident, we can go on and look at a concrete example so that you're more confident to deal with matrix multiplication. Yeah, okay. All right, in this example here we have matrix A. So notice that this matrix is a 3 by 2 matrix, and matrix B is a 2 by 2. So here we have the same number of columns and the same number of rows. Therefore, the result that we're going to get later on is going to have we're going to have a new matrix where the size is going to be 3 by 2. Okay, so the size is going to be 3 by 2. Okay, let's try and get the result of multiplying matrix A and B. So here we have A, B. What is A? A is -1, 3, 4, -2, 5, 0, and multiply that with -3, 2, -4, 1. Okay. And as I said just now, the new matrix is going to have this size 3 by 2, so we can start thinking of having 1, 2, 1, 2, 1, 2. So this is 3 by 2 matrix. We need to think of the values to fill up on this particular positions. Yes. Okay, so now what we're going to do is let's think about what value that we need to fill up right here. So in order to fill up this position with a correct value, what you need to consider is you need to consider taking the first row, and then you consider the first column. So here we're going to have -1 times -3 plus 3 times with -4, and the result is going to be 3 minus 12, which is -9. So that's the result that we're going to consider in this position. This is -9. Okay. Right, next we're going to consider this row with this row with this column. Okay, so here we have the second row with the first column. So the second row and first column will be at this position. Okay, so here we have 4 times -3 plus -2 times -4, and the result is -12 plus 8, and this is just -4. So the result here is going to be -4. Next, if you consider the third row and the first column, therefore the result is going to be at this position. Third row, first column. Okay, so right here. Then we have 5 times -3 plus 0 times -4, and the result is -15. So that's it. So this is -15. So we have -9, -4, and -15. Okay, next we move on to the second part. Here we're going to, at this position, what we have is we need to consider at this position, this is the first row and second column. So the first row with the second column. All right, so here we have -1 times 2, -1 times with 2, plus 3 times with 1. And this is going to be -2 plus 3, which is 1. Okay, so the result is going to be equal to 1. And then at this position, this is the second row and second column. So here we've got second row and second column to be considered. So 4 times 2 plus -2 times 1. 4 times 2 plus -2 times 1. So 8 minus 2 is going to be equal to 6. The result here is 6. And finally, here for the last position is at the third row and second column. So here we got third row, second column, 5 times 2 plus 0 times 1. So 5 times 2 plus 0 times 1, the result is 10. Now we're just going to put the result right here at this position. Okay, so that is the product of A and B. And the next question is asking you to find whether it is possible or not to obtain the product of B and A. Well, if you consider multiplying B and A, matrix B and A, let's see, here we have -3, 2, -4, and 1. And A is again -1, 3, 4, -2, 5, 0. Before you start multiplying and so on, you need to check the size of the matrix. Well, for this one is a 2 by 2, and this one is a 3 by 2. Well, notice that these values here are not the same values. This is the number of rows, and this is the number of columns, and this is the number of rows for this matrix. Since the values here is not the same, therefore the multiplication process cannot be done for these two matrices. Right, so it is not possible to find the result for B times A. Okay, let's move on to the next idea of power of a matrix. And before we look at this statement given here, let us consider a very simple case. Let's say the case of having matrix A, and here we have to the power of 2. What does it mean? So basically it means that A is going to be multiplied with itself. Matrix A is going to be multiplied by itself. Now, in order for multiplication process to be executed, remember that the size has to be the size of a matrix is important. Okay, let me just illustrate this with a simple example. Let's say A is a m times n matrix. right? So if A is a m times n matrix, then the size of A is going to be m times n, and A here is also going to be m times n. And can you see what the problem is? The problem is, the problem is we don't have the same value at this position. If we don't have the same value at this position, then the multiplication process cannot be executed. Yes? Therefore, A cannot just be any matrix. A cannot just be any matrix. And in order for us to execute the multiplication process, A must be a square matrix. So what is a square matrix? A square matrix means the number of rows is the same as the number of columns, which means the size is going to be, for example, a 2 by 2 or a 3 by 3 or a 4 by 4. So in this case, we're going to have maybe an m times m. So when it multiplies with itself, this matrix also has m times m, and then the result is going to be a square matrix as well. Yeah, so that's the reason why at this part here you are seeing a specific matrix mentioned, which is it is a square matrix. Okay, in order to have it multiply by itself, the matrix has to be a square matrix, cannot just be an m times n, cannot just be any matrix. And once we have established that, the result here follows the usual law of exponent. Okay, so when you have a to the power of r, a to the power of s, this exponent here can be combined together with this process. So we have r plus s, and this one here, when you have r and here we consider another exponent s outside, we can just simplify that by multiplying these two together. So here we have a, and the exponent is r and s, r multiplied with s. Okay, so here is a simple example. You can see here we have a2 times a3. This is a matrix, and it can be simplified as a to the power of 5. Okay, so you just add up these two exponents together. And the same thing for this one, it can be simplified to a to the power of 6, well, by multiplying 2 and 3. More examples related to the power of matrix will be seen in the near future. Yeah. All right. So now let's just move on to the next idea, which is transpose of a matrix. The idea of this is very simple. Basically, when you have matrix A, the size is m times n. Therefore, if you want to find the transpose of this matrix, the transpose of this matrix is denoted by A, and here we have T. So AT here, the symbol here represents the transpose of matrix A. And the result here is going to have a different size, which is n times n m matrix. So you can see that it is sort of reversed. The position of n and m are reversed. And how can we find the transpose of a matrix? Well, it is obtained by interchanging the rows and columns of A. That means the ith column of the transpose matrix is actually the ith row of the original matrix A. And I think this idea is better illustrated if we look at the examples. Okay, so that's what I'm going to do next. I'm going to talk about the examples here. How can we find the transpose of matrix B? So matrix B here is going to be, as it says here, you are going to interchange the rows and the columns of A, of the matrix. So in this case, our matrix is B. So this is the row, and you're going to change it, and it will become the column. This is the first row. So the first row will become the first column in this matrix. So here we have 2, 5, 0. I'm just copying each element here and position them as a column. So this is the first row, becomes the first column in the new matrix. So this is a second row, and it will become the second column in the new matrix. So that's the idea of interchanging the rows and columns of that original matrix. Yeah, so that is B transpose. Now what about C transpose? Again, the first row is going to be the first column. So here we got 3, 1. Second row is going to be the second column, which is 4 and 5. So that is C transpose. Let's do it again. D transpose is going to look like this. Again, first row is going to be the first column. Second row is the second column. So we're done with that. Okay, next, E transpose. First row, 3x. Second row is y and 2. And that's it. Pretty easy, right? Now let's move on to the idea of symmetric. A square matrix. Okay, we're very specific here. We have a square matrix. And if you want to determine whether it is symmetric or not, we have to check whether the result here holds true. So if you want to know whether it's symmetric, it can only be proven if you are able to show that A is equal to A transpose. Now as an example, here we've got like two matrices, A and B, and you have to determine whether these matrices are symmetric or not. So our first step is of course to obtain the result of this transpose, A transpose. Okay, so for A transpose is, again, first row becomes the first column, 1, 3, 2. Second row, second column. Third row, third column. And clearly you can see that the result of it is the same as the original matrix. So here we can see that A is equal to A transpose. Therefore, A is symmetric. Okay, so that's it. Next, if we look at the next example, so here we have matrix B. What is B transpose? B transpose is 1, 2 becomes like this. The first row becomes the first column, and here it becomes -1 and 3. And clearly from the result here, we can see that B is not equal, matrix B is not equal to B transpose. Therefore, B is not symmetric. Okay, I think that's all for now. Thank you very much for watching, and I'll see you in the next video.